All right, when we take a look at this chart, we have some states, 6 states, having to do with their debt and having to do with their population. So let's take a look and see what's going on with those. Question number 1. What is the sum, so we're going to add, of the debts for the first 3 most populous states? That means the ones that have the most people. So that would be these 3. So we want the sum of those 3. Well, let's get those turned into scientific notation. So right here, there's where the decimal is. This is obviously a large number. I need it to be right there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 4.07 times 10 to the 11. Okay, what about this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 3, that gets it right there. 3.37 times 10 to the 11. And for Texas, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 2.76 times 10 to the 11. So now if we want to add these up, we need the same scientific power. Well, it just so happens that they are all 10 to the 11. So those 3 are all good. So we can just keep it as a 10 to the 11 power. So this is all going to be times 10 to the 11. Then I'll go ahead and add the digits as they come. So I need the 4.07 plus the that's 3.37 plus the 2.76. So when we go take a look at that one, we can add those up. I'm going to go just grab a quick calculator and add those up. So what were they again? 407, 337. So what is happening here? 4.07 plus 3.37 plus whatever the other one was. 276. 2.76. 10.2. So all of this part becomes 10.2 times 10 to the 11. And now we have to fix that. So I need this decimal to be between 1 and 10. So I'm going to move it that way 1 time. That means the 11 gets moved that way 1 time. So we have 10 to the 12 for the power and 1.02 at the beginning. So there is the sum of all of the most populous, the debt of the most populous states. What's the sum of the debt for the least populous? Okay, so let's do that for these. For North Dakota, Vermont, and Wyoming. Okay, I'm going to change colors here. 1, 2, 3, 4, 5, 6, 7, 8. So now to get the decimal there, I only have to move it 9 places. So that's 4 times 10 to the 9. This is the same number, so this is also 4 times 10 to the 9. And 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 2 times 10 to the 9. So thank goodness when we add these, we already have it all as times 10 to the 9. And then the inside numbers, we had a 4 and a 4 and a 2. So I have a 4 and a 4 and a 2 to add up. So 4 plus 4 is 8 plus 2 is 10. So we have 10 times 10 to the 9 power. Now, of course, that's not usable. We've got to take this decimal that's back there, right there after the 0, and put it right there. We got to have it between 1 and 10. So I want 1.0. Now, if I move to the decimal 1 to the left, I'm going to move the exponent 1 to the right, which makes that now a 10 power. 1 times 10 to the 10. Okay, the last question on this one is how much larger is the combined for the most populous than that of the least pops? So how much more? How much more is the red one than the blue one? So what we want to take, we want to do some subtraction there. We want to know how much more that is. So we want to take the 1.02, there's the big one, times 10 to the 12. We want to take that big one and subtract it from this little one, 1 times 10 to the 10. Okay, so that's going to tell us how much more the bigger one is. Well, in scientific notation, now we have to have these to be the same. So I'm going to go ahead and make this answer in 10 to the 12. It's personal preference, but I like to pick that one. I'm going to pick the bigger one. So I'm going to make all of this be in times 10 to the 12. Okay, well, that's great. Then this one is already done. Then I'm going to subtract. Now I need to get this one to be times 10 to the 12. So, okay, so here's a 0, here's a 1. So out here's like 10, 11, 12 on the number line. And the goal is to get it to become a 12. So I need that 10 to go this direction. So I need that 10 to go that direction twice. Okay, that means this decimal is going to go this direction twice. Once puts it in front, and once more adds a 0. So it's going to be 0.01. Now they are both in 10 to the 12ths. So I need 1.01 minus 0.01. Well, that's easy to do in our head. That's 1.01. And there's our solution to the third one there. Okay, so for number 4, they want to know the sum of the population of the three most populous states. So you're basically going to do the same thing. Here are the 3 biggest states. They would like you to find the sum of that one. So I'm going to let you go ahead and do that one on your own. Here we want to know what is the sum of the population of the least populous states. Okay, that's going to be the sum of these 3. So go ahead and find the sum of those. Make sure you answer it in scientific notation. Okay, number 10 says, how many times greater are the big 3 than the little 3? How many times greater is 8.3 10 to the 7 than 1.8 10 to the 6? It's kind of like saying, how many times greater is 10 than 2? And we would say 5, because how many times greater? If we want to do the inverse of times, if we want to find out how many times greater it is, we would divide the large one by the small one. And that's the strategy here. I'm going to take the large one and divide it by the small one. So the large one is 8.3 times 10 to the 7. And I want to divide that by 1.892 times 10 to the 6. Okay, division now for the exponent part of division. For division, we're going to subtract them. We want the first one, subtract the second one. So the power is going to be the top one, subtract the bottom one. So our power is going to be 1. So our final thing here is going to be times 10 to the 1 power, which is just the number 10. Then I need to go to my calculator and do this part. 8.3 divided by 1.892. Okay. 8.3 divided by 1.982. That was the number, right? 1.982, yeah. Is 4. I'm going to take that to the 18. 4.19 if we round that. So that's going to be 4.19. And that's between 1 and 10, so we got lucky right there. That's what it is in scientific notation. Now, that's kind of a weird number to say how many times bigger are the big states than the little states. We say 4.19 times 10 to the 1. Well, 4.19 times 10 to the 1 is just the number 10. See, that's the same thing as 41.9. So basically, the big states are 42 times bigger than the small states. I'm going to write, it's approximately 42 times bigger. That's how much bigger that power, that one extra power is. It makes it 42 times bigger than the small one. All planets around the sun in elliptical orbits. They're not circles, they're ellipses. So Uranus's furthest distance from the sun is 3.00410 to the 9, and its closest distance to the sun is 2.710 to the 9. Using this information, what is the average? Now remember, average is add everybody up and divide by how many there are. So we're going to add all of these up and divide by 2. So our strategy here is we're going to go 3.004 times 10 to the 9, add that to 2.749 times 10 to the 9, and then we're going to divide that by 2, just the number 2. Okay, so let's get the addition first. When we add, we don't need to do anything to the power. The power stays the same. So I already know this top is going to be times 10 to the 9. Then I'm going to come over in my calculator and add these parts. 3004 with 2749. 3004 with 2.749. 5753. Okay, and we want to divide that by 2. Now we can think of that as 2 times 10 to the 0, because 10 to the 0 just means 1. That means 2 times 1, which is still 2. See, that would allow us to do the top minus the bottom. That would allow us to do 9 minus 0. So our power is going to still be a 9. You can think of it that way. Or you don't have to have that. You don't have to think of it like that. We can think of the 2 as just a 2. See, the 2 is going to go with the number part. The 2 is going to be part of the divider right here. And then the power is going to be this top 9 minus whatever the power is down here, which there isn't one. So either way you think about it, the power on the 10 is going to be a 9. So you can just go ahead and decide which kind of person you are there, how you like to think of that. But either way, we have 10 to the 9 power. So I need 5753 divided by 2. 5753 divided by 2. 28765. And lucky for us, that's already between 1 and 10, so there's no need to fix that scientific notation. Number 3, here are the masses of the inner planets of the solar system. So here's the 4. Now, okay, let's see here. See, that's times 10 to the 23, so it looks like Mercury and Mars are the 2 small ones, and then it looks like Earth and Venus are bigger by 1 0. So they're 10 times bigger, basically. Okay, so let's take a look and see that was just an observation. Let's look and see what they want us to do. What is the average mass of all 4 planets? Okay, remember average. We're going to add them all up and divide by 4. So we need to add them. Well, if I'm going to add them, I need them all to be the same power. So I think I'm going to crank these smaller ones up a notch into 24. So I'd like to make that one times 10 to the 24. So that 23 is going one more up the number line. So that decimal is going one more down the number line. So that one's going to be 0.33022. So there's Mercury. Same thing here. I'm going to go ahead and make that 23 a 24. So on the number line, that's going up 1. So that's going to be times 10 to the 24. That means our decimal on the number line is going down 1. So 0.64185. So now I have them all in times 10 to the 24. So I'm going to add them all up and have a power of times 10 to the 24. So I'm going to go get my calculator now and add them all up. So 0.33022. 0.33022 plus 4.8685. 4.8685 plus 59722. 9722 plus 0.64185. 0.64185 is a grand total of 11. How about I'm going to round it right there at 1181. Okay, so let's call that 1181. So there's all the additions, but averages, add them all up, divide by how many there are. So I'm going to divide by 4. Now remember, again, I can think of that as 4 times 10 to the 0 if I want to. I personally don't want to. I'm just going to take the 4 with the number that it belongs with. So the 4 is going to go right there. It's going to be part of that division. And then the power is going to be 24 on the top. Subtract the power on the bottom, which is not there. So we know our power is going to be 24 in this case. Okay, so I've got times 10 to the 24, and I need 1181 divided by 4. I already have it on my calculator, so I'm just going to say divided by 4. So we got 295. Whoa, what happened to my mouse? Okay, and there we go. 2.95 times 10 to the 24. Number 4, the speed of light is 300 million meters per second. The sun is this many meters away. How many seconds does it take for sunlight to reach the Earth? Okay, so that's sounding like a division problem. If we take this giant number and divide it by this smaller number, we should have how many seconds are left. So let's go ahead and do that. Let's take this 1.5 times 10 to the 11 and divide it by 300 million. Now, I'm going to turn that into 3 times. So if I'm going to turn this into a scientific notation kind of number, right there is the decimal. 1, 2, 3, 4, 5, 6, 7, 8 puts it right there. So it looks like it was a move of 8. So it's times 10 to the 8. I did that now because now the top number is 11 minus the bottom number is 8. My power is going to be 3. So I know it's times 10 to the 3. I'm going to go to my calculator and ask for a help here. 1.5 divided by 3, you may already know what that is, but 1.5 divided by 3 is 0.5. Okay, not quite good enough. We do not have it be the decimal between 1 and 10, so I'm going to move it one spot that way. That means the 3 is going to come one spot that way on the number line. So our final answer is a 5 for the coefficient, and the power 3 went down to a power 2. Okay, now that's kind of weird. Let's think about it. Asks for how many seconds does it take for sunlight to reach the Earth? Well, 10 to the second, that means 10 times 10. That's 100. This means 5 times 100. That means 500 seconds. Well, I just out of curiosity, how many minutes would that, if we divide that by 60, what is 500 divided by 60? 8.33. That's the same thing as 8.33 minutes. Takes 8 minutes about for the sunlight to reach us. So the sun that you see outside is 8 minutes old. Okay, number 5. The mass of the moon is this big number. It takes approximately 26 million moons to equal the mass of the sun. How big is the sun? So we need 26 million of the moons to make one sun. So let's take that 7.3 times 10 to the 22. That's the moon. We need 26 million of them. I'm going to write that 26 million with in scientific notation to make it easier on me. So I would put the decimal right there. So that's 367. So I'm going to call that 2.6 times 10 to the 7. That's the big number that we need there. So I need to multiply those together. I need the moon times 2.6, 26 million of them. Okay, remember for multiplication. We're going to add the power. So we're going to go 22, add 7. So I know that my power is going to start out as a 29. So I have times 10 to the 29 power. Now I'm going to go to my calculator and help out a little bit. 7.3 times 2.6. 7.3 times 2.6 is 1898. So I need the 1898. You have to show me this step. If I'm going to let you use a calculator, I need to see this step. Now fix it. So I got to put it between 1 and 10. That makes the 29 go to a 30. So we have 1.898 times 10 to the 30. Okay, let's take a look at number 6. Here's the mass of the Earth. The mass of Pluto is this number. Compared to Pluto, how much greater is Earth's mass? So we want to know, okay, how much greater? This one doesn't say how many times greater. It says how much greater. That implies subtraction. That's a little, there's some English language there. If it would have said how many times greater is Earth's mass, we would divide that. But here they want to know how much greater. It's like if we have the number 9 and the number 3, how much greater is 3 from 9? See, that would be 6. If they would have said how many times greater 3 is from 9, we would have divided it, and it's 3 times bigger, but it's how much we have. The difference is 6. So this English is talking about the difference between them. So we're going to do some subtraction here. Okay, so I got 5.9 times 10 to the 24. And I want to subtract. Okay, let's take a look at this. I'm going to, of course, call this 1.3. Okay, so I got to move the decimal all the way to there. There's 3, 6, 9, 12, 15, 18, 21, 22. So there we have it in scientific notation. I need to make them the same. So I'm going to, on the number line here, I'm going to go for 24. So here's 0, 1, 2, 3, 4, 5, 6, 7, 8, up to 24. So my goal is going to be 24. So I want this to be times 10 to the 24. By doing that, this one is already good. That is times 10 to the 24. But I do need to fix the 1.3. So let's get to fixing the 1.3. Right here is 22, and my goal is 24. So that 22 is going that way twice. So this decimal is going that way twice. Once in front of the 1, twice puts an extra 0 there. So we have 0.013. Now I can do the subtraction. 5.9 minus 0.013 is 5.869. This part right here ended up being 5.869. So we got 5.869 times 10 to the 24. That the power itself does not change. Okay, number 7. What is the combined mass of the Moon, Earth, and Pluto? Okay, the Moon is up there at 7.3 times 10 to the 22. We want to add that to the Earth, which is right here, 5.9 to the 24. And then Pluto, we already figured it out, was 1.3 10 to the 22. Okay, I'm going to go for 22 this time because 2 of them are already that. So if I try to make all of these times 10 to the 22, see, this one's already done, 1.3. This one out here is already done also, 7.3. So all I'm going to have to do is figure out the 5.9. Okay, so for some reference, here's a number line. My goal is to get it to be a 22. So I'm going to put a little star on that one. That's what I want it to be. But this one is a 24. So I have to go that direction 2 spots. So that 24 is going this direction 2 spots. So the decimal is going this direction 2 spots. One spot makes it 59, and another spot makes it 590. So that's what I have to add up. 590 plus 7.3 plus 1.3. Well, 7.3 and 1.3 is 8.6 plus 590. So it's going to be 598.6 times 10 to the 22. Okay, 598 is not within the range of 1 to 10, so I am going to move this decimal back 2 times. So we have 5.986 times 10 to the, okay, if I go that way 2 times, the 22 is going to have to go in the right 2 times to make it 24. And there's our answer to that one. Okay, number 8. The sun produces 3.8 10 to the 27 joules every second. How much energy is produced in a year? Okay, note a year is approximately 31 million seconds. Okay, so we have 3.8 every second and we have 31 million seconds. So let's multiply those things together. So we're going to go 3.8 times 10 to the 27. That's per second, and we have 31 million seconds. So I'm going to put the decimal right there. 1, 2, 3, 4, 5, 6, and one more is 7. So let's go 3.1 times 10 to the 7. Okay, multiply is add the exponent. So 27 plus 7. So I now know that it's going to be times 10 to the 34. Then I'll go have my calculator help me with 3.8 times 3.1. 3.8 times 3.1, 1178. Okay, we got to fix that. So 1178 needs to go that direction once. So we have 1.178. Makes the 34 go that direction once. So 10 to the 35. Number 9, on average, Mercury is about 57 million kilometers from the sun, whereas Neptune is about that big number from the sun. What's the difference? Okay, the difference. So we want to subtract these. What's the difference between Mercury and Neptune? Okay, I think I'll take the bigger one minus the smaller one. This one is the bigger one. It has 9. If we move that once, it would have 8 more zeros, whereas this one only has 6 more zeros. So the 4.5 times 10 to the 9 is the bigger number. So let's take that 4.5 times 10 to the 9 is the bigger number, and I want to subtract. Okay, let's put the decimal right here. 1, 2, 3, 4, 5, 6 with one more is 7. So 5.7 times 10 to the 7. I think I will go for a 9 on the number line. There's 0, there's 1. So here's the 9. I'm going to make that the goal. So there's the 7. So starting at 7, that means the 7 has to go to the right. So if 7 is going to the right 2 places, this decimal is going to the left 2 places. Once puts it in front of the 5, twice puts it out there. So it's 0.057. This one is already a 9, so I'll leave it 4.5. And all of that was times 10 to the 9. That was my goal. So on my calculator, I need 4.5 minus 0.057. 4.5 minus 0.057 is 4.443. So there we have it, 4.443. Do nothing to the power, stays a 9, and we're between 1 and 10. Last one, number 10. The mass of the Earth is this big number. The mass of Venus is this big number. Find their combined mass. Okay, that's going to be really easy because they're already times 10 to the 24. So we're not hardly going to have to do anything to this one. Times 10 to the 24. I need 4.9, 5.9 plus 4.9. 10.8. Only thing we're going to have to do here is fix it up. So let's come this direction once. So 1.08. And this direction once. 10 to the 25. Okay, given the mass of the sun is approximately this big number, how many times larger is the sun than the Earth? So that's a division. We want to know how many times bigger is the big one. We want to take the small one and divide it into that. So I'm going to take the 1.9 times 10 to the 30 for the sun. That's the large one. Divide it by the Earth, which is 5.9 times 10 to the 24. See, the sun has got 6 more zeros on it. So that the sun is way bigger. So let's take a look at this one now. We want to do division, so we will subtract those exponents of 30, subtract 24. So that's going to give us a times 10 to the 6. And I'm just going to come to my calculator. 1.9 divided by 5.9. 1.9 divide 5.9 is 0.322. So let's move that one spot to this direction, which makes it 3.22 to get it between 1 and 10. And the 6 has to go this way on the number line, making it a 5.